You ever just pick up a pencil and start doodling? It's like one of the most basic human things we do, right? But what happens when you want to move past a quick sketch? What if you want to create something, well, perfect? That's exactly where the world of geometric construction comes into play.
I mean, take a look at these drawings. They seem pretty simple, don't they? A little stick figure, a wave, some eyes. But if you've ever actually tried to draw a perfect circle or a really symmetrical shape just by hand, you know the struggle. The lines get all wobbly, the curves are kind of off. It's close, sure, but it's never quite right.
So that leads us to the big question right here. How do we bridge that gap? How do we get from that shaky, hand-drawn guess to a figure that is mathematically, undeniably perfect?
Well, it's not magic, it's geometry. It's really two different worlds. On one side, you've got the guesswork of freehand drawing. It's all approximations in those wobbly lines we were talking about. But on the other side, you have geometric construction, where just a couple of simple tools can give you clean lines, perfect arcs, and just true precision.
And that's our quest today. We're going to explore how a few super basic instruments can totally transform our ability to draw, taking us from messy to, well, masterful. Let's see how it's done.
And our first magical tool is this guy, the compass. This simple little device is the absolute key to unlocking one of the most fundamental and perfect shapes in the entire universe, the circle.
Okay, let's do a quick thought experiment. Imagine a single point, just sitting there on a piece of paper. Now, how would you find every single point that is exactly 4 centimeters away from it? You could, try with a ruler, marking dot after dot after dot, but would you ever really find all of them?
This is exactly where the compass just shines. It's a super simple 3-step deal. You set your distance, say 4 centimeters, you fix your center point, and then you just swing the pencil. Every single point that pencil touches is guaranteed, absolutely guaranteed, to be the exact same distance from the center. No guesswork whatsoever.
And just like that, you've drawn a perfect circle. See, a circle isn't just a round shape. It has a real definition. It's the collection of every single point that's an equal distance from a center. That distance, by the way, is called the radius. A compass is basically a perfect circle-making machine.
Okay, so we've mastered the curve. Awesome. But what about shapes with straight lines? Like squares and rectangles. Well, it turns out they have their own set of rules we can follow, just like a blueprint.
Come on, think back to grade school for a second. What really makes a square, and not just any old rectangle? They both have 4 sides, 4 corners, but there's a really key difference, right?
And here are those rules, laid out plain and simple. For a rectangle, the opposite sides have to be equal, and all the angles have to be perfect 90-degree corners. But for a square, the rules get even stricter. All the sides have to be equal, and the angles are still 90 degrees. These rules are going to be our guide.
So, let's put that blueprint into action. Mission for right now. Let's construct a perfect square with sides that are exactly 6 centimeters long.
So, first we start by drawing our base, exactly 6 centimeters. Then, to follow that 90-degree angle rule, we construct a line that's perfectly perpendicular at one end. And to follow our equal sides rule, we measure exactly 6 centimeters up that new line to mark our next corner. Easy enough? We do the same thing on the other side, creating another 90-degree corner. And here's where our compass comes back in to be the hero. We can use it to perfectly measure and mark that final corner, making absolutely sure all sides are precisely 6 centimeters. Then we just connect the dots and voila! A perfect square, no wobbles, no guesswork.
All right, so we've got perfect curves down, we've got perfect angles down. Now for this last part, let's combine all of this logic to build something a little more creative. Let's make a little piece of art.
So here it is, our final challenge, this simple little house figure. The rule is all the outer lines have to be exactly 5 centimeters long. We have the tools, we know the rules, so how in the world do we build this thing?
Okay, let's break it down like a puzzle. The bottom part is just a 5 by 5 square. We literally just learned how to do that, so that's the easy part. The real mystery is where exactly is the peak of the roof, this point A. We have 2 clues. We know it has to be 5 centimeters from corner B, and it also has to be 5 centimeters from corner C. And this is the beautiful moment where it all just clicks together. We grab our compass, First, we set it to 5 centimeters and draw an arc of all the possible points that are 5 centimeters away from B. Then, we do the exact same thing from point C. And that one single perfect spot where those two arcs cross, that's it. That's our point A. It's the only point in the universe that follows both of our rules at the exact same time.
So think about what we just did. We didn't guess. We didn't have to erase and try again. We used logic, the simple, powerful idea of two arcs intersecting, to find the perfect point with absolute certainty.
And once that key point is locked in, well, finishing the rest of the house is a piece of cake. We just used a couple of simple tools and a logical process to create something that is both precise and, honestly, kind of beautiful.
So what we've really learned here is that geometric construction is almost like a language, like a code. The compass and the ruler are your programming tools, and the rules of shapes are your commands. So now that you understand the code, what are you going to build? What masterpiece will you create?